Hello, this is Mrs. Pullen for Algebra 2. In this video, I'm going to go over a couple of problems from the Unit 6 review sheet, specifically the skills solving systems of inequalities graphically, problems 19 and 20. So the first thing I'm doing is I have a function f of x, which is an absolute value function, and we have a function g of x, which is a horizontal line at y equals negative 21. And I'm looking to find the solution where f of x, the y values of f of x are greater than g of x. So the first thing you're going to do is identify the points of intersection. And the points of intersection are negative 3, negative 21, and 11, negative 21. And what I like doing is making two vertical lines that pass through the x values of those points of intersection. And they should be dashed in this case because we're not including those values. Okay. So next, I'm specifically looking for the y values of f of x. F of x is the absolute value function, is greater than negative 21. Well, that would be anywhere above that line y equals 21. So when I shade, and let me use the markup shade, those values of x are in between, let me change that color to a yellow, are in between the points of intersection. So now I make my number line. So here's negative 3, here's 11. Remember, you're looking for the x values that make that true. So that's anywhere in between. And because it says greater than and not greater than or equal to, you don't include the endpoints in. In inequality notation, you would write it as negative 3 is less than x is less than 11. If you're a little confused about which way the inequality signs go, choose a value in between, like let's say 2 is in between negative 3 and 11. Notice that 2 is greater than 3 and at the same time less than 11. So that may be helpful if you have trouble writing in inequality notation. In interval notation, it's negative 3 is less than x is less than 11. Notice we have parentheses as opposed to brackets because we're not including those values in. So this is inequality notation, and this is interval notation. You can a little bit use the graphing calculator to solve. I pre-entered in GeoGebra f of x and g of x. There are just a couple of strange things that you need to do with programs like GeoGebra and Desmos, otherwise you can't get the shading. You have to define what y is. So I have that, and in this case I'm looking to see f of x, which has to be greater than y, has to be greater than g of x. And then it gives you the shading, otherwise it doesn't seem to work. And we could see we're looking in between those two lines. So I don't find that to be a perfect solution, but some of you may like that better. Again, you're looking for the x values to make that true. Okay, let's go on to the second problem, which is slightly more challenging, but similar. In this case, you actually have to graph it out for the problem. F of x is the left-hand side of the equation, so negative 1/2 x minus 10 squared plus 8. And g of x is the right-hand side. That's the horizontal line at 6. Notice we're looking to find the values of f of x that are less than or equal to, so you include the endpoints, to g of x. So the first thing you need to do is to graph it, and what I like doing is to find the vertex or turning point. And since it's in vertex form, you can do that easily without the calculator. You reverse what's inside the parentheses, so it's 10, and the y value would be 8. And you set up a table, and I put the 10, 8, that vertex in the middle, and I normally choose 2 values less, 3 to 4 values less than the vertex, and 3 to 4 values greater than the vertex. And you can get that, you can easily then get it from GeoGebra. So I pre-entered the function already, and now I go into my table and I can pull off the values. So I'm going to pull off the values. This was 0, this was 3.5, this was 6, this was 7.5, 8, and then it starts repeating. So 7.5, 6, 3.5, and 0. And now we're going to graph this. Make a nice smooth curve. Whoop, that wasn't too good. Let's try this again. And label f of x. And now g of x I'll make in green. It's a horizontal line. And again, arrows at the end. Next, we need the points of intersection. So the points of intersection are 8, 6. And the other point of intersection is 12, 6. And I'm going to make 2 vertical lines at those point of intersections. They're solid in this case because we're including those values in. Okay, and whoop, so it's 8, 6, and then the other one should be 12, 6. I have to slide that over a bit. Okay, so now we're specifically looking for y values that are less than or equal to g of x on this function. So if I'm looking at that, that's these y values for f of x are less than g of x, okay? So we're looking, the x values are to the left, less than or equal to 8, and greater than or equal to 12. Okay, so here's my number line. Here's 8, here's 12. We're actually including those values in, and now we're shading to the left of 8 and to the right of 12. So in inequality notation, x is less than or equal to, because we're including 8 in, or x is greater than or equal to 12. Again, if you ever have trouble figuring out which way, choose a value of x. So 7 is less than or equal to 8, and 13 is greater than or equal to 12. That's inequality notation. But in interval notation is negative infinity to 8, hard bracket. Remember, you can't get to infinity, and that's why it's a soft bracket. Or it's hard bracket, because we're including 12 in, to infinity soft parentheses. And that's the answer. So graphically, you can do graphically. So let me go back to the algebra. But this one I find, what you do is if you say f of x, let's see if this will work, is less than or equal to g of x. Let's see if that will work. So for some reason it works when you're doing parabolas and lines, but when I try to do an absolute value and a line, it didn't work unless I did that, setting that y equal to that absolute value function. So I'm not quite sure why, but that's how I got the other one to work. But this worked out when it's just a parabola and a horizontal line. You can do it and look at how beautiful it mimics the actual shading that we did here. In any case, I hope that was helpful, and I will see you tomorrow.